The basic units of measurement. I want to impress upon you that units are very important. Here's a sentence. When my son was 7, he walked 3, and when he was 4, he could... Oh, gosh, that's a typo. That's better. When my son was 7, he walked 3, and when he was 4, he could throw his baseball 8. Why didn't you tell me? Because it's... Okay, third time's the charm. When my son was 7, he walked 3, and when he was 4, he could throw his baseball 8 and tell us that his school was 5 away. Does that make much sense? No. What on earth are we talking about? Could be all kinds of different things. There's no units on those numbers. What it's supposed to say is when my son was 7 months, he walked 3 steps. And when he was 4 years, he could throw his baseball 8 feet and tell us that his school was 5 minutes away. That makes a lot more sense. Units make all the difference. If you go to McDonald's and say, I want 5, what are you going to get? Questions, puzzled looks. You're like, 5 what? You want a number 5 meal? You want 5 coffees? What do you want? We don't understand 5. In chemistry, we're going to use numbers. They're measuring something, and we need to write down 5 what? It's really important. There's two common unit systems, the English system and the metric system. That's probably the dean hanging up something in her office. Bang, bang, bang. I have to ask her about that. Now it's a little more rhythmic. Yeah, pound back at her. Feel free. Love it. Thank you. Okay, units matter. This is an interesting illustration. In 1999, NASA lost a $94 million orbiter because 2 groups of engineers failed to communicate about which units they were using. One was using inches, one was using centimeters. So what happened? They built the thing, they launched it, and the orbiter descended too far into the Martian atmosphere and burned up. Over a unit. Units are really important. Okay? So what units are we going to use? Well, scientists use the International System of Units, also called the SI system. And it's SI, not IS, because of the French, and I'm not going to try to pronounce that because I took Spanish in high school, which turns out to have been much more useful than French. It is based on the metric system. It is not exactly the same as the metric system, although the units that they use mean exactly the same thing. So I will use SI system and metric system interchangeably. For the purposes of this class, the difference does not matter. Just think of it all as the metric system. In the SI system, there are 4 quantities that are measured, among others: length, mass, time, and temperature. And we're going to talk about these first 3. The 4th one will show up in chapter 3. So the base units. The meter is the base unit of length. It's important to know roughly how big these metric units are, because if you've grown up in Central California using the English system all your life, you might not have a grasp of how long is a meter. A meter is slightly longer than a yard. Most of you have an idea of how long a yard is. A yard's about this long. Okay, think of a yardstick. A meter's a little bit longer. They have a very precise definition of it, having to do with how far light travels through a vacuum in a certain amount of time, and they use this fancy instrument here. We're not going to worry about that. The base unit of mass is the kilogram. This is a picture of the official kilogram. It's this block of metal kept all locked up under very controlled conditions at the International Bureau of Weights and Measures in France. And everything's measured off of that. We need to know how big is a kilogram. A kilogram is a little more than 2 pounds. So it's a relatively big weight, okay? So, if I ask you how much your calculator weighs in kilograms, don't tell me it weighs 5 kilograms, because it does not weigh 10 pounds, right? You say, well, it's definitely less than a kilogram. We want to have an idea of how big these units are. The kilogram is a unit of mass, which is different than weight. Mass measures the amount of matter in an object. Mass never changes. The amount of matter in an object doesn't change. Weight measures gravitational pull. Weight will change if you go somewhere with a different gravitational pull. Your weight on Earth is different than your weight on the moon, but your mass is the same in both places. So there's a difference. Is anyone planning to leave the planet during the semester? Travel to the moon or Mars or anything? I mean, actually, not just like in your mind, but really leaving. No, I didn't think so. So then, as long as we stay on the planet, they're basically the same. The gram is another unit of measure. Kilogram is a little bit big to use in the chemistry lab. We don't want to weigh out, pounds and pounds and pounds of stuff, right? It's a big unit. So in chemistry, we use the gram. The gram is another common unit of mass. To give you an idea of that, a US nickel weighs about 5 grams. So a gram is a much smaller unit of mass than the kilogram. And the gram and the kilogram are related to each other. 1 kilogram is equal to 1,000 grams. And we'll talk more about relationships like that in a minute. The other base unit of time we need to talk about is the second. And this means exactly what you think it does. It's the same second that the little hand on the clock is ticking off. We have a very precise definition of what a second is. Read that if you're interested. I'm not going to test you on that. What's cool about the SI system and the metric system is instead of having completely different units for different sizes, they use prefix multipliers. So you have the same base unit, you stick a prefix in front of it that makes it bigger or smaller. I live in Reedley, I work in Fresno. What English unit would I use to measure the distance between work and home? The mile. Why wouldn't I use inches? It's just going to be a ginormous number of inches, right? We generally want the size of the unit to be similar to what we're measuring, so that we don't have a really large number of that unit or a really small number of that unit. I wouldn't want to measure the length of my stylus in yards or miles, right? Because it would be a very, very tiny number. I would probably choose inches in the English system. In the English system, you've got inches and feet and yards and miles, and the relationships between them seem a bit random to me. 12 inches in a foot, 3 feet in a mile. I can't remember, no, 3 feet in a yard. You have to stop me when I go off like that. 3 feet in a yard, and I can never remember the yards to miles, but I can remember feet to miles. 5,280. That's a nice round number to remember. In the metric system, everything is based on powers of 10. And they use the same prefixes for mass, and for length, and for time, and for volume, and for everything. So you'll learn one set of prefixes, and you've got this wealth of units that you can use. And that's why there's a list of metric prefixes on the memorization quiz material that you need to memorize. So these prefixes make the unit larger or smaller. As an example, the prefix kilo means 10 to the third power. 10 to the third power is 1,000. So 1 kilometer is how many meters? Well, we just put in what kilo means. It's 10 to the third meters. 1 kilogram is 10 to the third grams. 1 kiloliter is 10 to the third liters. It's a pattern, and it's used on all the units. So once you learn it, it becomes very, very convenient. and there's no fractions. These are the metric prefix multipliers. I gave you some of these to memorize for the quiz, mostly these guys here in the middle. We have to be precise when we use these. There's a capital M and there's a lowercase m, and they are different. They're very different. Mega means a million, 10 to the 6th power. Lowercase m is milli, and that means 10 to the minus 3rd power, 1/1000th. So one makes the unit larger, one makes the unit smaller. And then another prefix that starts with m is micro. We've already used the capital M and the lowercase m, so now we're going to go to the Greek letter m, mu, and so you need to recognize that guy. I think of it as like a lowercase u, but it's got a tail on the front. Or you could think of it maybe as a backwards y, but that's mu. So we need to know these symbols and their meanings. These decimal ones are there for, I don't know why, but I don't recommend that you memorize it that way. Memorize it as powers of 10. Okay? So on the quiz, I might ask you, what's the meaning of centi? And then it's multiple choice. I'll give you 4 or 5 choices, and you should be able to pick out 10 to the minus 2. There might be 10 to the minus 1, 10 to the minus 3, 10 to the minus 5, 10 to the 4, different ones. You pick out the correct one. What is the most convenient unit to express the dimensions of a poliovirus, which is about 2.8 times 10 to the minus 8 meters in diameter? We want a unit that's close to the size of what we're measuring. So which of these is close to 10 to the minus 8th meters? Megameter, millimeter, micrometer, or nanometer? Micrometer, micro means 10 to the minus 6. So this is 10 to the minus 6 meters. Nanometer is 10 to the minus 9 meters. We'd like the unit to be a little smaller than what we're measuring, so that, we'll end up with like 2 instead of 0.2. So this sort of a question, I wouldn't give you that on an exam, because really either of these would be okay choices, but I think D is the best choice. It's a smaller unit than what you're measuring, and so you're going to end up, it's going to be 28 nanometers. Derived units. Derived units are formed from other units. Many volume units are derived. If you take a unit of length and cube it, raise it to the 3rd power, it becomes a unit of volume. So if you measure a cube and it's 1 meter on a side, the volume of a cube is the length times the width times the height. Meters times meters times meters, you get cubic meters. Cubic centimeters, cubic millimeters. Those are units of volume. A meter is a unit of length, but a cubic meter is volume. We also have volume units that are not derived, liters and milliliters. Most of us have a good idea of how big 2 liters is, right? 2-liter bottle of soda. 1 liter is about the size of a quart. And we'll save that one for next week.